Welcome, everyone, to Building SaaS on AWS, the AWS SaaS Factory show for SaaS builders on Twitch. My name is Anthony McClure, Solution Architect with the AWS SaaS Factory, and your host for today's show. If you are building SaaS or even in the process of learning how your application could be hosted in a SaaS delivery model, then this is the show for you. In this week's show, I'm joined by both Anubhav Sharma and Umberto Simonsi, my co-workers from the AWS SaaS Factory. We're going to have a discussion today about how you can streamline provisioning and deployments in SaaS environments. Anubhav and Umberto, welcome to the show. Would you like to introduce yourselves?
Yeah, sure. I can go first, Humberto. So my name is Anubhav Sharma, and as Anthony mentioned, I'm a solution architect here at the AWS SaaS Factory team. I've been working here at AWS for about 4 years now, based out of Boston office, helping customers building SaaS solutions on AWS, of course. So now, thanks everybody for joining the show today. Humberto.
Yeah, and my name is Umberto Somensi. I'm also a solutions architect at the SaaS Factory. I'm based in London. I've been with the SaaS Factory for 3 years now with Anubhav and Anthony, and just really excited to be here and talk about this super interesting and very important topic for SaaS builders.
Well, welcome to both of you, and thank you for joining the show today, and to our audience members that are with us as well. If you have any questions today for our guests, please feel free to put them into the chat, and also be sure to say hello to our moderator for today, Bill Tarr. Anubhav, for the audience members that may not be familiar with who the SaaS Factory is, can you talk a little bit about who we are and what we do?
Yeah, absolutely. So we are basically a group of solutions and business architects, and our job is to basically help customers and partners building SaaS solutions on AWS, right? So not just technically, but also from business perspective, helping them go to market and build architectures and launch their SaaS solutions as soon as possible. And that's what we have been doing. We have a global team all over the world, and we basically work with partners and customers on daily basis, helping them building SaaS solutions. Yeah, that's pretty much what we do. I mean, and one thing I just want to mention is, like, obviously we do that in a one-on-one setting, but we also do that in a one-to-many fashion, right? So we also produce a lot of scale content and talks like today as we are here. Yeah, I mean, that's about SaaS Factory.
And we capture like the challenges that SaaS builders are facing in the field, and we try to build content and bring new patterns that people can benefit from. So I think this is one of the topics that SaaS builders are asking us about very, very commonly, and we're trying to kind of build new ideas and establish a mindset for addressing this problem, right? And
Yeah.
Yep.
Excellent. Speaking of the topic for today's show, we're looking at streamlining deployments and provisioning in SaaS environments. And I think of deployments and provisioning, and immediately the term that comes to my mind is DevOps, right? But I imagine DevOps may be somewhat different or can have differences in SaaS. Is that true?
Yeah, I mean, here's the thing. If you're running a SaaS business, what that basically means is you're hosting the solution on behalf of your customers, right? And what that basically means, you need to be agile and invest in automation. In fact, we have maybe a couple of slides, Anthony, if you want to just quickly share the screen, or I can share my screen and we can just talk about that. Yeah, I mean, so as I was mentioning, right? So agility and automation is the key when building SaaS solution, right? And like you and Humberto, and we have been working together like for last so many years. Like, we always hear customers having challenges in terms of how to frequently release, how to onboard tenants. Like, I have heard stories like, what, my onboarding time is in days or weeks to onboard a new customer. I've heard that from customers. So I guess in a SaaS business, it is very important to invest in those automation needs, and more specifically when you have per tenant resources, right? So in many cases, we do see some customers who are building SaaS solutions having those per tenant resources, and the idea of creating new resources when provisioning a tenant and the idea of keeping all those environments in sync is basically the challenging part in a SaaS environment.
So when you're talking about infrastructure, let's say on a per tenant basis, that really kind of gets into the different SaaS isolation models, right, and the different types of models with SaaS. So is that kind of what you're referring here to as well?
Yeah, and actually we have a slide to talk about that as well. So typically, we see two kind of deployment models that ISVs and SaaS providers, adopting, right? So the first one on the left side is the silo model. And what that basically means, you have dedicated resources for each tenant, right? So each
Mm-hmm.
tenant get their own cluster, maybe VPC, maybe AWS account, depending upon your isolation strategy. And on the right side, what we have is a pool model, which obviously means you're sharing resources across all tenants. And pool model again and again have proved to be more efficient, more cost optimized, right? But then as we work with many SaaS providers, especially who operate in this highly compliant enterprise B2B space, right? We see them building solutions which have a mix of both, right? So let's take an example, right? Let's say you are an ISV who's migrating your solution, or you're an ISV who has an on-premise solution, right? And your business is asking that, hey, I want to go to market for us with a SaaS solution. Can we migrate this on-premise solution to a SaaS offering? And you really don't have time to invest in re-architecting at this point, and you want to go to market and get the MVP as soon as possible, right? So in those cases, one way you can potentially do is you can have a silo environment where you can have one VPC or separate clusters or accounts per tenant, right? That's one example. Humberto, can you think of more? I mean, I'm pretty sure you have seen
Yeah,
more, right?
this could be a
Yeah,
tiering construct as well, right? Where you have your mid-tier, like tier twos and tier three tenants kind of sharing resources, because maybe they are more cost conscious. And then you have your tier one customers having their own kind of dedicated sort of resources, right? But that doesn't mean that these environments are going to be different from the perspective of your application, right? So that's the key to the story here, right? You want the environments to be uniform so that you can manage them collectively, right? So there might be some configurations that change, maybe sizes of tasks and things like that you vary per tier, but in essence the application that is running is uniform.
yeah. I think, Humberto, you brought up a very important point about configuration, right? So let's say you have a premium tier where you want to guarantee certain SLAs, right? And the way your application is architected, there is no way for you to guarantee those SLAs if you're using a pool environment, let's say, right? So maybe you don't have noisy neighbor prevention built into the system, right? So those cases where you have those SLAs, and maybe your customers are fine paying that additional premium also, right? For a silo environment.
So given the fact that if you are dealing in either a with silos where your tenants have all of these resources that need to be provisioned specifically for them, or even in a hybrid model where you've got both pooled tenants and you have siloed tenants interacted together inside of your SaaS solution, I can really see how that would be pretty difficult to maintain and organize and to work with as you go forward. So is that really kind of the crux of the problem that we're getting to?
Yeah, exactly, right. So basically, how do you manage the provisioning of those resources, right? How do you manage the configurability of those environments? Like, how do you make sure that you keep all those environments in sync, right? So that's what we want to get to today. And what we want to do is we want to like show you by mean of actual code examples, right? So the first
Right.
example that we have, which Humberto is going to walk us through, is built using EKS, right? So in EKS cluster, how we can follow the GitOps approach, how we can leverage like open source tools like Helm and Flux V2 and Argo CD to kind of keep your environments in sync. And then I'll also walk you through a serverless approach using code pipeline and step functions. And it's an interesting approach because we also have a concept of staggered deployments, which we're going to talk about when we reach there, right? So yes, that's the problem statement. Now,
Right.
just one more slide, maybe if Anthony is okay with me to present this whole problem statement we're talking
Absolutely.
about, right? So I think we
Absolutely.
have kind of covered this already. Like Humberto and I have talked about this already, but let's just maybe put a conceptual mental model in place, like what problem you're trying to tackle, right? So in this example, let's say you have a SaaS application, and this is your application plane, right? So in this example, we have three tiers: a free tier, a standard tier, and a premium tier. And in this example, again, this is an example, right? A fictitious example, right? We have free tier tenant having access to your blogging feature. Standard tier tenant have access to your blogging and SEO, which is basically search engine optimization feature, right? And then your premium tier tenants have their own silo resources, right? Again, have access to all resources. And in this kind of model, as Humberto mentioned, right, the configuration, you have the flexibility of having a configuration per environment. Again, the source code, the release, they are all on the same release. That's important to understand. They are all like being deployed from a consistent build. But you could still have, let's say, for your Lambda functions, if you want some sort of warm instances running all the time for your platinum tier tenants, right? You can have provision concurrency done. You can have maybe a task count of 3 for your ECS Fargate cluster, so that you build the high availability for your premium tier tenants, right?
Mm-hmm.
And then now in these kind of environments, right, and this is where we're getting into the problem statement, how to solve it, right? What we really want our customers to do is build some sort of control plane to manage the provisioning aspects, right? And this is where your tenant provisioning service comes into play, basically, right? And the idea for this provisioning service is to build some sort of configuration. Now, think about it this way, that when you're provisioning new tiers or new tenants into the system, what you're doing is you are basically building these configurations. Now, you can store these configurations in different ways. Like Humberto will show you how to store them in GitHub for his GitOps EKS approach. I'll show you how to store in DynamoDB, right? So there are different ways you can store the configuration. And then what you really want to do is you want some sort of deployment pipeline, which is basically self-healing, right? And the job of this pipeline is to make sure it always keep your tenant environments in sync with this configuration, right? And not just for provisioning, but as we were mentioning, for continuous deployments as well, right? So basically now any developer committing their code into the source code repository, right? So this deployment pipeline should be able to, in case of serverless, let's say they should be able to build a SAM package. In case of EKS containers, they should be able to build the container image, right? And they should be able to update all these environments and keep them in sync, right? So that's like the high level problem statement we're talking about.
So we do have a question from the audience for our guests.
Oh, wow. Nice.
Yeah. So the question is the silo model similar to multi-tenant and pool model to single tenant? And I think this is an interesting question because it really goes back to nomenclature and how we talk about these things, right?
Yeah, no, thanks for asking that question, because it is important to get these terminologies correct. Because otherwise, I don't think so we'll be able to understand what we are talking about today, right? So it's an important question, and the way we kind of articulate and formalize this in our white papers is both silo and pool are multi-tenant model. They are both variation of multi-tenancy. The difference being, in a silo model, you have resources per tenant. In pool model, your tenants share all the resources, right? And then we have something called as hybrid model, where this is basically an example of hybrid model, where you have a mix of pool and silo based upon your tiering strategy, right? Humberto, anything you want to add there?
Yeah. So in a nutshell, the pool model is a model where the tenants are sharing the resources. So it could be, maybe a Dynamo table or a database instance, or maybe the pods within your cluster. And the silo model is when the tenants are not sharing resources, right? So the resources are dedicated for given tenants, and that there is the value proposition for each one of these is different, right? So there are things that you have to sort of overclock on if you choose the silo model, right? And then there are benefits and things that you have to do and engineer in order to have a healthy sort of pool model, right? And if it's very common that SaaS providers will implement both, right? As we said before, like you will have your sort of enterprise, tier 1 customers, and you will have a handful of those, and those will maybe deploy themselves into their own dedicated resources. But then you have your lower level, lower tier kind of tenants, which will share resources. But those decisions are very specific to your use case and to your workloads and to your requirements, right? So it's hard to say that one is better than the other. You have to analyze what you're trying to do, and the markets that you're trying to reach and what the requirements are, and then build an architecture that will support these models.
Yeah. In fact, we have a tenant isolation white paper. I mean, we can probably paste the link, which talks about the pros and cons of these two models as well. Yeah.
Thank you very much for the question. So at this point in time, then, Anubhav, do you have anything else that you want to
No, I
show,
think
or-
this is basically the premise of today's discussion. So I would let Humberto kind of dive deep into the EK solution now, actually.
Excellent. So,
Sure. Cool. So I think this is my screen, correct?
yes. Yep,
Okay.
should be able to see that.
Basically, just to give you an overview of what we try to do. So I built this with a couple of colleagues, container specialists, and we sort of identified this as a common kind of request and a common challenge for customers, right? So DevOps in SaaS, and then this is very specific to people that are using EKS, right? So are within the Kubernetes sort of ecosystem, right? And we try to build like a pattern and we chose some technologies, right? And I'll talk about those in a second. But some of these components could be interchangeable, right? So we use Flux as our reconciler, and we use Argo workflows as our workflow tool. But there would be other tools that you could use, if you are more used to them, if you prefer them, etc. Like for example, Argo CD could be a reconciler, and people also use Backstage or even GitHub Actions as a workflow engine, right? So the solution, basically, imagine that you have a developer, right? And in our sample implementation, there are two microservices, right? Those two microservices basically represent the application plane. So the application planes is basically the services that deliver value to your customers, right? So on Anubhav's example, it would be the blog API, and maybe another service that is actually delivering value to the customers, right? And so the first thing that we do is we package that definition of what the application plane looks like, what are the services that deliver value to my customer, right, into one single template, right? And this is a template, right? So we use Helm here to package the resources that are going to be deployed within the EKS clusters, so pods and services and service accounts, that kind of stuff. And then we also package infrastructure resources. So maybe your microservice needs a Dynamo table, and another microservice needs some SQS queues, right? So we package those templates, and here these are application plane definitions, right? And they do not contain any sort of tenant specific information or tier specific information, right? So, and then when comes the new actor in this story, right? Because at this point, we're basically talking about basic DevOps, right? So, you are building and you're packaging your application, and then you are deploying. But in SaaS, you have this new actor in the story, which is the provisioning service, right? Part of your onboarding service. So maybe now, I need to provision a new tenant, and I need to build resources for that tenant, right? We call that the silo model, right? So maybe here the provisioning service will trigger a message, right? And we have implemented a workflow using Argo workflows that will basically take that definition of the environment template, right? And then create an instance of that, but then containing information configuration that belongs to the tier and that belongs to the tenant, right? So that is a concrete sort of implementation of the template, right? And we call that a release config. And this is sort of like the terminology that is used in Helm, right? And what will happen is that when Argo Workflows runs, right, Argo Workflows will actually create the infrastructure needed for that tenant to run, right? And this is the application plane of your SaaS application. And will also write the release config on GitHub, right? And then we have the reconciler, which is Flux, which is watching that GitHub repo and looking at the desired state of the environment in GitHub and making sure that the cluster looks the same as the desired state. That the actual state, which is the cluster, the nodes and the namespaces and the pods, right? They match the definitions that are defined in GitHub. And now we
so
yes,
Humberto, there's a lot going on here, right? So just a couple of
sure.
quick questions that come to mind. So we have these tools, right, that are not necessarily AWS tools, right? We have Helm, we have Terraform, we have Argo Workflow and Flux that are being utilized here. Those tools themselves, I think I heard earlier mentioned that these are open source tools. Is that true? Is there licensing costs to use these?
There are no licensing costs, right? Both Argo workflows and Flux will run within your EKS cluster, right? So there is some compute cost associated with this, but there is no licenses that you have to pay to use these tools.
And if I'm following along correctly here, so if we were going to develop this from the get-go, we would need to create these environment templates, right? That represent the environments that we're going to deploy to either different tiers, depending on tiering structures or types of infrastructure. And then the process of what Argo ultimately would be doing is actually creating from those templates the concrete example for a new tenant that's being onboarded. Does that sound correct?
Perfect. Exactly. So you have the blueprint of your application that is represented by Helm and Terraform, and the workflow process basically hydrates those templates with tier-specific and tenant-specific configuration to then generate these release config files that are then used to actually deploy to the cluster.
Yeah, I think we can just to your point, Anthony, right? We can probably have three categories, right? Three stages, or you can say like bootstrapping, as you mentioned, you bootstrap your infrastructure, all these CI/CD pipelines and templates, and then there is a provisioning aspect to it where you provision new templates, and then as Humberto probably will describe or describing already, the continuous deployment or updation of these environments, right? So there are three different stages basically running going on here. Yeah.
And maybe the last question I have, and then I'll let you continue, is in relation to the AWS cloud here as well, right? So we have Argo, and it looks like it's interacting with this box that you're referencing here as infrastructure resource, and then we have Flux that is working in a GitOps way with the EKS cluster. So is that the boundary here that we're talking about, like AWS resources and then inside the cluster?
Exactly. So there is a wrinkle here to our solution, right? That the reconciler Flux does not reconcile infrastructure resources, so resources that belong to AWS, right? It can reconcile resources that live within the cluster. So what we did was within our workflow, right, we're actually applying the infrastructure changes, and we use Terraform. This was a choice based on just the popularity. We did a little survey and we decided to go with Terraform. So I will, on the next slide is the last slide that I have, and then I'll give you a quick demo. I will show you like a list of steps for so yeah, let me actually get to that.
Yeah, let's go to the demo actually.
So just before like getting into that, right? So then the other sort of challenge like that we talked about is like within the context of provisioning resources, right? And creating new resources for tenants, your developers are still making changes, right? So and I will also show you how we can package those changes and let Flux apply those changes, and we use the concept of semantic versions here. And I will kind of show you how that works and give you some caveats to that process. But let's get into the workflows, right? So this is the onboarding workflow that we have implemented, right? We use Argo workflows. There are basically 3 steps to this, right? It's very straightforward. So the first step is that we're going to clone the repo, right? So we clone the repo to basically get access to all the releases that exist and to get access to the templates, right? So we are cloning that GitHub repo that contains that Flux is watching, right? And then the second step is we're going to deal with infrastructure, right? So the first thing we are going to do is basically get the template. So what is the infrastructure that is needed for a new application plane for a tenant, right? That is a template. Then we are going to substitute the variables here, right? And create a new release file. Then we are going to apply those changes. So we use Terraform to apply those changes. And then finally, we'll push those changes to GitHub, right? So we're kind of mimicking GitOps here, right?
Mm-hmm.
By making sure that the changes that we made are reflected in the repository. And then with the resources that live within the cluster, this process is slightly simpler because now we are going to, it's very similar, right? So we get the definition first, then we substitute variables, and then we push the release file, right, to GitHub here, right? And now Flux is responsible for creating the new resources within the cluster, right? So here Flux is actually helping us reconcile the changes.
And you are basically following the namespace per tenant approach, right here in
Yes.
this example. Yeah. Okay.
Yeah, we use the namespace per tenants. I mean, there is a pool namespace, so I can actually kind of start showing you that, right? So, can you guys see my screen? Let me just kind of check here. Is it big enough?
Maybe a little bigger.
Maybe just
good. Just,
one or two notches up.
Okay, is that better?
Yeah, that's
good
to me. Yeah.
Okay, so I just kind of listed the namespaces that exist in my cluster, right? And I can start by saying, look, you got Argo workflows installed there and you got Flux installed there, right? So these are sort of the two building blocks, right? So Argo workflows, our workflow engine that will execute those steps, and then Flux, which is the reconciler, right? So Flux is watching our GitHub repo and it's checking for changes that it needs to apply to the cluster. And then I have already installed like a pooled environment here. So that's an environment where multiple tenants will inhabit, right? Maybe this is your free tier, right? And then I got also 2 tenant namespaces here. And these are silo tenants. This could be your premium tenants, right? And I already kind of installed those guys just to kind of, exercise the application a little bit here. And now let's have a look at Flux, right? So you can see here that Flux is watching the tenant Helm chart. So we have one tenant Helm chart that is being watched here by Flux, right? So that's the important line here, right? And then we can see that all our tenants, so basically these guys here, right? They're all using the same Helm chart. So they're all using the same definition, right? And now we are going to see the releases, which are the actual tenants within the system, right? You can see here that I have 4 tenants, but I don't have all these namespaces, right? Because some of these tenants are pooled, so they are living within the pooled namespace. And that's basically it, right? So let me just kind of exercise some of these guys here so you can see them replying. Okay, so I kind of hit tenant 1 here, right? There's 2 microservices. They just kind of echo. I got a producer microservice and a consumer microservice. And you can see here that the tenant ID is tenant 1, but the environment is pool 1, right? So it means that this tenant is a pool tenant. So the requests that are made by this tenant are fulfilled by the pods that live within pool 1. Yeah. And I got another one here. Right, so tenant 4 is also kind of
both the tenants sharing the same set of resources, basically, right?
Exactly.
They are pool tenants. Yep.
Yeah, and then I got a tenant here that is silo, right? So you see tenant 2 here is being delivered by the environment tenant 2, right? And the same goes for tenant 3. Let me just do a quick request on this guy here. Right, so there you go, and you can see the microservice version here as well, right? So now let's kind of exercise this and onboard a new tenant. So when I need to onboard a new tenant, I basically need to pass in some information to Argo to start the process, right? So this is the tenant sort of information, right? And I'm saying the tenant ID here, and I'm also giving the provisioning service the model that it needs to provision, right? So I'm saying, okay, I need to build a new tenant. So I already got tenant 4. Let me kind of do tenant 5 here, right? So tenant 5, I save this file. So this is, you can engineer this as a message. So Argo workflow supports sensors. So this could be like an HTTP message or even an event bridge event. We haven't not implemented that yet, but
I mean, typically in a SaaS environment, you'll have a provisioning service that will take care of doing all of this for you, right? So just assume for now that you have something which is mimicking this.
We're just doing it manually in a file.
Yeah, which is not the ideal way, but this is just an example, right? Yeah.
So let me just kind of get this guy started here. Okay, so I created a workflow. So this is going to build the new tenants. Now let me kind of show you the Argo workflow window running here. Just a moment. Let me just kind of get this going. Okay, so this is forwarding. So now I can go here, refresh this guy, and you see I got the workflow running here, right? So now my workflow is running, and you see those steps that I described, right? So first step is to clone the repo. The second step is to apply infrastructure. This is a pool tenant, so it's not going to do anything. It still needs to run the process, but the process basically will not create anything because this tenant doesn't need any specific resources. And then the last step is to create the resources in the cluster that relate to that tenant, right? So, and this is basically just kind of making a commit, pushing some code changes to some configuration changes to GitHub, right? And I'll show you that in a second. Let's just this thing finish here. Okay, cool. So now this is the repo that I'm using to test this. So if I refresh this, you can see that the process pushed a change into GitHub, and it's saying adding new tenant in pool model, right? So if we kind of just have a quick look at what that did, it basically created this new file, tenant 5 pool YAML, right? And also added to the customization YAML, which is the file that Flux watches for, right? So Flux watches for changes here, and then it pulls the files to basically reconcile. So let me just
has Flux already kicked off at this point then and is doing its job?
It is. So, but let me just kind of kick off like another tenant, because Flux has an interval that watches, right? So I configured it to a minute. So let me kick off another tenant here. Just double check. So 6 siloed.
So we're creating a silo tenant in this case.
Yeah, yeah. And now let's have a look at Flux, right? So Flux get all. And you can see that the tenant 5 is already there, right? So Flux already noticed that there was a change, right? And kind of brought up tenant 5 there, right? So it's saying, the Helm release and that the release reconciliation succeeded. So let's just kind of quickly exercise this guy here.
And that is a pooled tenant, right, for tenant 5.
Exactly.
So there, yes, okay.
Yeah, yeah. So yeah, if we kind of check the namespaces, there won't be any namespaces for this tenant, right? So we still got the same tenant. So now with the new tenant, with tenant 6, which is silo, we will have a new namespace here, right? So let's just check like how how this guy here is going. Okay, so this is still running. And okay, so let's just kind of let this thing finish here. Or there is already like a change in the for the infrastructure, right? So now because this is a silo tenant, there will be 2 commits for this tenant, right? So there is a new infrastructure for the tenant, which we're looking at now, and I'm basically just adding Terraform resources.
A new S3 bucket, basically, you're creating for
this. Yeah, I was about to say, is this like an S3 bucket, or it could be a DynamoDB table, or whatever.
Exactly.
Whatever
AWS resources.
Yep.
Yeah, we just created this just to sort of have something to kind of play with, right? But it could be anything, any resource that Terraform controls could be created by this process, right? And then now I have already like the new tenant, right? So now this is the configuration. So the application, the EKS cluster resources, so the Helm release, right? So it's the second commit, and you can see that there's already like a file there, and with the definition of that tenant, right? And again, this is created using the template plus tier configuration plus tenant sort of specific attributes, right? So, okay, so this guy is done. So let me just close this and stop this thing here just to make sure. Okay, cool. Now let's see Flux has already kind of picked this up, has not picked it up yet. Yeah, Flux,
Well,
it can take some moments for this to change, but let me kind of take you through some of the code here. Does that make sense?
Mm-hmm.
yeah. Well, one quick second, Umberto. I
Sure.
just want to make sure anybody that has joined us after we've started, this is Building SaaS on AWS, and I am joined today with Umberto Siminci and Anubhav Sharma, who are discussing deployments and provisioning of SaaS environments. Sorry.
Okay, so while we wait for tenant 6 to be provisioned, let's just kind of check the structure here, right? So first of all, let me start with the chart, right? So this is the sort of the blueprint for the application, right?
That's the Helm chart, right? Yeah.
That's the Helm chart, and it has a version here, right? And the values.yaml is where you are actually defining what what this chart contains, right? So there's the definition for the producer microservice, and then there's the definition for the consumer microservice. For one thing, like for example, here the resources are defined here, but this could be, replaced based on the tier, right?
And
So
this is like the part, right, Humberto, important part in a SaaS and differentiating factor, right? So, and I'm pretty sure you will show the tenant template hybrid pool silo. This is where you can change the configuration by tier,
exactly.
right? Yeah.
Exactly. And then then our process, the workflow process, will use these templates here, right, to basically to create the release files, right? So and
the
they
hydrated versions of the templates.
the hydrated version, and they rely
Cool.
on the Helm tenant chart, and they pass in the values that the chart requires, right?
Yeah.
So basically all the configuration that you need here, that you need per tier, could go here, right? And then your chart takes those configurations, right? And you could have different configuration on a
These are
silo
basically
level,
parameters, right? You're passing
just
the
parameters.
Yeah.
Yeah,
Okay. Yeah.
yeah, exactly. And then once the process runs, and I don't have my local here updated because we just kind of did that on the server, right, on GitHub. So I got more tenants in GitHub than I have here. But basically, this is what the the Helm release looks like, right? So it's referencing the tenant chart, etc., right? So in a nutshell, that's the structure. And then here is the definition of the workflow, right? So basically, these are the 3 steps of the workflow, right? So just some shell scripts, and very simple. They, cloning the repo, and then here, slightly more involved, basically, translating, taking the models, and then hydrating those models, and then basically applying the changes, right? And then pushing them to GitHub, right? So those are basically the steps. And then for the Kubernetes resources, you don't need to do that. We're just sort of creating those files and then pushing them to GitHub, and then relying on Flux to do the reconciliation. So hopefully Flux already kind of picked up the change here, and there it is. So
Here it is.
we got tenant 6 in there. So let's just exercise this guy. And there you go. So you got tenant 6, and it's it's living on its
Be a
own
new namespace as well, right?
Yeah.
Yep.
Yeah. kubectl get namespaces. Let's just check that very quickly. Yeah, so I got my 3 silo tenants with their own namespaces, and this is the tenant isolation posture that we chose for our sample application, right? And then you got the pool model, which has the other tenants, right? So tenant 1, 4, and 5 live within the pool model. So the last thing that I can show you is now if we make a change. So because we are using this thing here, right? So we are basically using a wildcard on the version of our Helm chart. And this means that Flux will push these changes automatically. So we don't have to really do anything. So the moment that we have a Helm chart, with a new version that is published to the ECR repository, right, that Flux is watching, Flux will automatically reconcile it, right? So let me just get that going, because that might also take some time. So here is the Helm chart. I've already pre-created that, right? And it contains a new version, so a version 2 for the 2 microservices, right? And the idea is that once I push this to ECR, then Flux will reconcile it. So let me just kind of check if my environment here is kind of doing what it's supposed to do. Yes. So now I'm going to push this to ECR. This. Okay. Oh, what? Yeah, it's a demo time, guys.
It's always the demo gods.
That's
right?
always
Yeah,
the case. But
it's
I think
demo time.
yeah, but the concept basically is like when you update the Helm chart, that whole process will just reconcile, right? I mean, that's pretty much what Flux V2 is doing.
Exactly. So the idea is that once I push this, right, and I can show you here, right? So I got my sort of like my definitions, right? So I got version 1 here. I mean, I don't know why I got forbidden there, but anyway, like once I get once this gets here, right, version 2, right, what will happen is that Flux will, let me just kind of do a Flux get all here. Right, Flux will understand, because it's watching this Helm repository, that there is a new version available, right? And it will basically change all the versions of these guys to version 2, which is basically deploying the new version of the microservice. So I will get this to 2 here, right? And it will do all these things in parallel, right? And the cool thing about this process, and there are many ways that you can engineer this, is that you can basically now describe a process where you have patches and minor releases and major releases, and what you allow Flux to deploy automatically, and things that you want to sort of kind of have a more involved process where you have to manually or automate a process to do that, but actually change the file here, right? So let's say if I change this to version 1 or version 2, I have to go in and change the definitions on these files to do that, right? So that's basically the process here.
Well, this is all fantastic, Umberto, and of course I know the demo gods sometimes come up and bite you, but I think one I think the biggest burning question right now that the audience may have is will this be available for folks to actually interact with and work with?
So we are in the process of pushing this to AWS samples, and we're just kind of doing like the sort of final security checks and stuff like that. And then there's also a reinvent session that we're building, and we are evolving this process, right? So we're making it slightly more evolved, and we're kind of adding more features to this. And I think that the SaaS DevOps story, there's a lot of things, right, that's kind of belong to this, and this is just sort of our starting point, right? So we would love to kind of get people's sort of ideas and sort of understand their challenges, so that we can start incorporating and making this solution more robust. Things like, we talk about onboarding, but there's also offboarding. There's also processes for moving tiers. There's also like configuration changes. How do you sort of engineer configuration changes in your environment, right? When, maybe a tenant purchases some more sort of quotas or things like that, right? So how does that sort of reflect in your infrastructure in a way that, and this is the key here, right, that you can enable the two main things, the two value propositions of this in SaaS, right? The first one is you want to build a consistent environment, right? Like you want to build like an environment that contains where all your tenants are running the same versions of things, right? So you can manage them collectively. Or developers, they don't have to worry if you have 10 tenants or 1,000 or 10,000 tenants, right? Because there's one version of your application that is delivered across the board, right? And you can manage it collectively, right? And the second thing is like this plays into your agility story, right? You want to allow your developers to make frequent changes, right? This is better for developers, this is better for your customers, and this will be better for your company in the long run as well.
Yeah, the goal of being able to do deployments at will, right, is a huge ability that we are always looking for in a SaaS solution. So that you're not having to go to those traditional development cycles of 6 months or a year, bi-yearly or something like that. You can deploy many times in the same week if necessary or makes sense for you and your teams. But you really have to have these kinds of processes and automations in place, and that's kind of the key point here to what we're looking at in order to enable that.
Cool. Yeah.
I know what went wrong, guys. If I can have like another 1 minute.
Sure.
Yeah, sure. Or I can just start the serverless and we can come back to this, Humberto, whatever.
Yeah, sounds good. Sounds good.
Whatever
Let's do
Okay.
that. Yeah, sounds good.
Yeah,
I just
so-
don't want to give
so
up.
we-
I don't want to give up. Let's do it.
No, that's all right. So we actually do have a treat today. We get 2 demos today, which is excellent. So Anubhav, you mean to share your screen?
Yep. Oh yeah. Okay. Well, I mean, so Humberto walked us through EKS, and I'm very kind of, I would say, impressed with the approach that we kind of landed up eventually, right? Of making sure all the namespaces are in sync through an automated way, right? I mean, but the idea here is again to give you more examples, right? Because this is not really the implementation, right? And these are example implementations and how you would approach this, right? And basically, to keep that spirit of examples, we wanted to give an example for serverless as well. And so in this kind of example implementation, what we have is we have a tenant provisioning service built using API gateway and Lambda functions. We have a DynamoDB table, which basically the tenant provisioning service, put some entries into, right? So if you might remember, like Humberto showed us that commits in the GitHub, right? Tenant 5, tenant 6, and so on. The idea here is to keep the configuration inside a DynamoDB table, right? And obviously this table has more columns than what I showed you, but the idea is to show that you can have, let's say, 1 entry for pooled tenants and 1 stack for pool tenants and 1 stack for tenant 1 and so on and so forth, right? So you'll have the entries for each and every stack, and provisioning service will basically kind of add those entries, right? And then what we have is the code pipeline. Now, if you see these 2 different colors, right? So the first job of this code pipeline, and this is where you might be able to correlate with the EKS example, right? Like the way we were creating those templates and those configuration files, and
That'd
the
be
way
like the DynamoDB table up here,
exactly right.
Yeah.
So now the way Flux V2 was able to reconcile all those environments and namespaces based upon those configurations, this is what our code pipeline is doing. And we are actually leveraging a step function to do that. So I'll demo you how that step function is working. And this code pipeline now is able to create environments when needed, but also this yellow line of updating environments when a code change happens, right? So I don't really have this arrow pointing to a GitHub commit or something, but assume that this code pipeline is monitoring your source code as well and updating these environments, right? And in this case, you have 1 pooled, couple of silos. Again, you can have as many number of these. It does not really matter, right? As long as you have this configuration in place. So we'll go into the demo, or I would say go into the AWS console and look into the moving parts. But before we do that, one more thing I wanted to show you. The step function approach that we have in this case is also using what we call as staggered deployments, right? And this is something not sure if you have experimented with or not, but in some cases, what we have seen SaaS providers doing when they're releasing new features to their customers, they typically release features to, let's say, your free tier tenants or some tenants, and where they can monitor the impact of the new feature, right, or the new release. And basically now your step function in this case will wait for an approval to happen before it deploys to your premium tier tenants, right? So we have a deployment in 2 ways. Wave 1 is when your source code gets deployed into your basic and standard tier pool environments, and wave 2 is when the source code gets deployed into your premium tier tenants, right? So let's look at how this works.
So this really kind of gives you the ability to do canary deployments or canary-like
Yeah,
deployments, right?
yeah. I like to call them staggered deployment just to keep it
Mhm.
consistent with the Amazon terminology of deploying, right? Because if you go to the Amazon builder libraries, this is what
That's what they're
we
called.
typically. Yeah, but yes, I mean, canary deployments is definitely basically what's happening is canary across tenants, right? In this case. Okay, so I might as well just stop sharing this thing and just show what's happening behind the scenes, right? So this is my table, DynamoDB table, basically, right? This is the table, and
Anubhav,
can you?
I think you need to reshare your screen.
I think so. You're right. Yeah. Present. I don't know what happened there. Sorry about that.
No, no worries.
Okay. How about now?
Yeah, there we go. Yep,
Got it.
we can
Okay.
see it now.
Yeah. So this is basically that table that we were talking about, right? Which is basically the provisioning service is kind of leveraging to maintain your configuration in this case, right? So if you see, right, when we provision a new tenant, we create a new entry, depending upon if it's pooled or silo, right? If it's a pool tenant, that tenant always gets onboarded into your pool environment, right? So we're not really creating any separate configurations for that pool tenant because it's already there. But if it's a silo tenant or a premium tier tenant, we create a new entry here, right? And then this code commit column is basically similar to the Helm chart version that Humberto was showing, right? So Humberto showed us how he's maintaining those Helm chart versions. This is basically the code commit ID of that deployment, right? So what code commit that deployment is that? And this is basically the name of the stack. And this is basically your wave numbers, right? So in this example, what I'm saying is that my pool tenants get deployed in wave number 1, and my silo tenants get deployed in wave number 2, right? So there is an approval built into between, and that approval could be automatic or manual. Again, in this case, we have right now just a manual approval, right? But we are working on building it more automated, where you can basically monitor your CloudWatch logs and make sure that there are no errors in CloudWatch for, let's say, maybe 4 hours, 6 hours, 10 hours, whatever duration you want to customize. And then if there are no errors in the new release, the release gets rolled out to your premium tier tenants, right? Basically. So let's understand how that is happening, right? So here in this example, I have, now again, this is serverless, right? So has to be a little simpler than what we saw in EKS. And I think here what we have is a single YAML file, which is, and we are leveraging AWS SAM to build our tenant infrastructure, right? And in this example, we have parameters, and here this is where you can pass those parameters like reserve concurrency, provision concurrency, depending upon what you want to configure for that tier, right? So in this example, as we have what we call reserve.
Are you showing a different screen, Anubhav? Because we don't see.
Maybe I'm not really sharing the right way then.
No worry.
So I just did a share screen, and maybe I should do an entire screen versus window.
Yeah.
Sorry.
No worries. There we go.
Yeah.
Here we are.
Okay, so I just switched from the AWS console to this repository. And by the way, this repository is public. And Anthony, if you want to give the link for the serverless SaaS reference solution, all of this code is in a public repository if you want to refer, right? So in this case, we have this SAM template where what we have is parameters. And one parameter in this example is Lambda reserve concurrency, right? And you can have provision concurrency and more parameters as you want. But basically in this example, we have 2, Lambda reserve concurrency and canary deployment preference, right? So you can customize these based upon your tiering configurations, right? Very similar to what we saw in the EKS example. Now, what you want to do after this is you want to build a CI/CD pipeline, right? So this pipeline have 4 stages in this, right? So this is a code pipeline. By the way, I'm in a code pipeline now. And what this pipeline is doing, it's monitoring your source code, right? And making sure that if there is any commit, it kicks off automatically. And what happens is it then builds that package.yaml file, right? So it will basically take that SAM template, do a SAM build, SAM package, and pushes the package.yaml to an S3 bucket, right? And this is the Lambda function integration inside the code pipeline now. So what we are doing is we have a Lambda function inside the code pipeline, which is basically now monitoring this table and preparing a JSON file. And I don't think so we have time to go into how that is done, but just think about it that it is preparing a JSON file, which is now being passed to the step function inside your code pipeline, right? And now this step function is kind of deploying, either creating or updating those stacks, right? And it will be interesting to see how that is done. So if I just open an existing execution, right, we won't be like...
Anubhav, it's almost like the step functions is your reconciler, right?
Exactly, right? I
Right.
mean,
Yeah.
absolutely.
Yeah.
I mean, if you just look at the
They all
input,
have the analogs between the two.
Yeah.
yeah, that's why we started off with that approach, right? Like how we want to conceptualize and put this into theory, and then these are just example implementation as we were mentioning, right? So this step function again have a stacks array, and you will probably notice 3 entries here, right? And these 3 entries are corresponding to your 3 items from the DynamoDB,
table.
right?
Mhm.
And in this example, what we have leveraged is an iterator approach, where this iterator is kind of iterating through all the waves, right? So we have, like, in this example, we just had one wave. I'm just having one wave, but you can implement multiple waves, right? And basically your map state is making 3 loops in this case. And if it has to create a tenant, it will create. So in this path, it is creating a new tenant. And if it has to update, it will go and update the tenant, right?
Nice.
So it's basically that step function is a kind of self-healing mechanism. And we won't go into too much detail. And we won't probably go into like the too much detail about how to kind of do the approval. But basically, this is where we have sent a message to an SQS queue, and basically we are trying to build that approval process. So now somebody can monitor the SQS queue and basically send a message back that's okay, this is approved, right?
And
Yeah,
once
that's
that approval would happen, then the second wave would then kick off at that point.
exactly. Then the second wave kicks off. It just goes through the second wave and update all the environments in second wave. So this is like a high level approach. Again, I don't think so we have too much time to go into like doing this, but the repository I think you already shared, right? Yeah,
Yes.
maybe one last thing I will show is the cloud formation. Like, so when you see those environments getting updated and created, you will just notice inside your cloud formation console, right? Basically. So and I see a question as well.
Yeah, that's a great question because it's leading right into this. Thank you, Annabelle.
Yeah, and I basically see a question there. And basically, what we're doing is one thing which I forgot to mention. These create stack and update stack steps are basically using the the SDK integration with CloudFormation. So these are basically calling, if you look at the definition, I should probably just edit this GM machine and show it right here. So basically what we're doing is we are calling just the create stack API itself, right? Yeah, that's it, I think, for now.
I'm
for
afraid,
the question
Sorry,
around
go
like
ahead,
the other resources, VPC and stuff, like in the SaaS GitOps example that we published, I mean, it uses the same pattern, right? But just kind of sits in another kind of folder where you have the sort of the initial sort of bootstrapping of your cluster and your environment, right? And then the tenants kind of live within those resources.
Yeah, you might want to follow those instructions. For basically what we do is, as Humberto mentioned, we create a bootstrap template first. We bootstrap the environments, and then we create tenant resources inside those environments.
I'm afraid, folks, that we're actually running right up on time here. So first of all, I want to thank Anubhav and Umberto, both of you, for being here today and sharing these great demos with us. And of course, to our audience and guests, thank you so much for joining us today on Building SaaS on AWS. Please join us for our next show, which will take place on October 4th, 2023, where we will have SaaS competency partner CleanState with us. We'll be talking about how they build a custom authorization platform using AWS serverless technologies like Annabov's talking about, and identity provider Okta. So for all of you and us here, happy building.
Thank you.
Thank you. Cheers, everyone.